to today's lesson. In today's lesson, we'll be considering work and machines. So under work and machines, let us begin with work. When we talk of work, a lot of people think carrying load, that is what is work. But basically, work means if there is a point. So if I move this point through a particular distance in the direction of the force, we said work is done. So work, if they ask to define work, work is the point of application of a force which moves through a distance in the direction of the force. So if I move this particular point, whatever it is, whether I load, if I move this load in a particular direction, it becomes work. So how do you remember work? Remember, we work for food. Just remember this. You work for food. Everybody here is working basically for food. When you work for food. And the food here, just to give you a mnemonic, food means force times distance. So when we are talking of work, we are referring to force and distance. So you can say work equal to force times distance. So work is force times distance. Just remember, we work for food, which means that force times distance. Now they asked to define for work. We said work is what? The point of application, moving a point through a distance in the direction of the what? The force. So work is defined. Okay, work is defined as, or we can say work is said to be done. When what? A point moves through. Alright, so as I was saying, we said when a point moves through what? A distance. Okay. When a point moves through a distance, okay. A distance when a force is applied, we said that work is done. Is that okay? So if you continue this one, now we said work is force times distance. So force times distance. So force times distance is going to give you work. So anytime they ask you work, remember food, force times distance. So the force times the distance will give you work. So some can say work is the product. Work now is a product of force and distance. Now that we understand that work is product of force and distance, let's take them one by one and look at it. Now we have to understand how to calculate for force. Good. But before you look at that one, work now has the unit, the SI unit. The SI unit for work is joules. Joules. Work is joules. Now looking at force. Now how do you remember force? Just remember we force man, just a mnemonic though. We always force our parents, and usually the mother, of course. So remember force man. The man here means that mass times acceleration. So we have force to be equal to mass, the product of mass times acceleration. Mass times acceleration. So if you have mass times acceleration, that gives you the force. So M-E. It means that force is equal to mass times acceleration. Now, mass we know is measured in kilogram, and acceleration, okay, is meter per second square. So anytime you have to calculate for force, how do you do it? Force, you multiply the mass times the acceleration. So mass times acceleration gives you force. Alright, so force, as I keep on reiterating it, force is mass times acceleration. Mass times acceleration. Now what I would like students to know is that anytime you are calculating for the force, remember why are we looking at force? Because work is food, which is force times distance. Now the mass should always be in kilogram. The mass should always be in kilogram. Now if they give you to gram, the unit is in gram, and you have to convert to kilogram, don't forget you divide by 1,000. Let's take an example. If I give you 5,000 grams, you have 5,000 grams. You have changed 5,000 grams to kilogram. What will you do? You divide this 5,000 grams by 1,000. If you divide by 1,000, you change it to what? Kilogram. So this is going to give us 5 kilogram. Okay, and so anytime they give you the mass, convert the mass from gram to kilogram. And how do you convert from gram to kilogram? You divide by 1,000. So when you divide by 1,000, you get a unit in kilogram. So that is how to calculate for the mass, how to convert the mass from gram to kilogram. Now we've tackled the mass. What of the acceleration? Acceleration, usually they give it to you in what? They can give acceleration due to gravity. And usually the unit given to you as what? Maybe 9.8 or 10. So let's take an example. How do you calculate for force? And I said force is mass times acceleration. Example: if a body of mass 10 kilogram moves through a distance, okay, calculate the force given G to be equal to 10 meter per second square. Now this is a question before us. They've given us the mass and we have to calculate for the force. Remember, ma, the a here is the same as the g, which is what? Acceleration due to gravity. So since you are calculating force, you know force is ma, which means mass times what? Acceleration. Now what's the mass given to us? The mass given to us as what? 10 kilogram. Now we don't convert because it's already in kilogram, we wouldn't convert. So I just multiply the 10 times what? Acceleration, which is also 10. You are going to get 100 what? Newton. Now there's a unit for force. Force is measured in Newton. So we've gotten the force to be 100 Newton. Remember here it was 10 kilogram and we need to convert the 10 kilogram because kilogram is what we are expecting to use. So 10 kilogram, and then the acceleration is also given to us as 10. So we've gotten 100 Newton. Or you can still write this one as what? 100 kilogram per meter per second square. And it's still the same thing. Kilogram meter per second square. Alright, so let's take this example again before we move on to our work. Now the question is, calculate the force exerted on a body of mass 1,800 grams. Take G to be equal to 10 meter per second square. Now we are calculating for the force. Now we know force is equal to what? Ma, which is mass times acceleration. Now our mass is given to us, but the mass here is what? 1,800. We know 1,800 grams, but then we have to convert this gram to kilogram. And how do you convert gram to kilogram? We will divide by 1,000. If you divide by 1,000, this is going to give you what? 1.8 kilogram. Now we've converted the mass from gram to kilogram, and we are now have to find what the force now. So now you can now say force is equal to mass here, which is what? 1.8 kilogram times the acceleration. Acceleration here is acceleration due to gravity, which is the g here, and that is given to us as what? 10 meter per second square. So with this one, 1.8 kilogram times 10 is going to give you 18 Newton, or you can write it as 18 kilogram meter per second square, and that's going to be the unit for force. Remember, work is food, force and distance. So in the very short period, we look at how to calculate for the force. So we can now quickly move on to work now. Look at what work entails. Work is what? Force times distance. So let's look at some examples of how to calculate for the work. Recap on work. So we said work is said to be done. If they ask you to define work, you can put the definition in this form. A work is said to be done when the point of application of what? A force moves in the direction of the force. Okay, when the point of application of the force moves in the direction of the force. So here the key word here is what? The force, and then it's moving. So force times distance. Good. Now let's look at an example on how to calculate for work. For example, if they give you, let's look at example, an object of mass 400 grams is carried through a distance of 400 centimeters. Full stop. Calculate the work done. Calculate the work done. Given G to be equal to 10 meter per second square. Now, in this particular example, we are to calculate for the work. Now, let's look at the question critically. An object of mass 400 grams is carried through a distance of 400 centimeters. Calculate the work done. So quickly, what will I do? I have to state the formula. Work, I'm searching for work. And work is what? Force times what? Distance. We all know very well. Now, we have to first of all calculate for the force, because in this example, they've not given us the force. So we have to calculate for the force and then the distance as well. Now, what is the force? Let's find the force ourselves. Remember, force is ma. We force ma. We force ma. It doesn't mean you don't force up your daddy. I know you force your daddy as well. So we force ma, which is mass times acceleration. Now we know force is mass times that of acceleration. But then the mass here is given in grams. So we have to convert the mass from grams to kilogram. Now we know the mass here is given in grams. So how do you convert it? We have to convert the mass from 400 to what? Into kilogram, right? So we know the mass is given as 400 grams, which if you convert it by divide by 1000, so if you divide the 400 by 1000, you are going to get what? 1, 2, 3. So you are going to get 0.4 kilogram. Now we've calculated for the mass, so we can now find a force. So how do we get that force now? So the force now we equal to what? Mass times acceleration. Remember, I'm to find for work, and work is force times distance. I needed to find for the force, and that's what I'm doing here. I'm searching for the force, and the force is mass times acceleration. Now the mass is, we've calculated for the mass, which is what? 0.4 kilogram. So 0.4 kilogram, okay, times that of what? What is the acceleration? The acceleration due to gravity is given to you to be 10. So times 10, which means that our force here will be what? 4 Newton. Now we have found the force. It means we've tackled out of the force. Remember, the question says to find the work, and work is force times distance. Now that we found the force, which is 4 Newton, we have to find the distance, then we can now find work. Now, please take note, the distance should always be in meters. And how do you convert? Anytime they give you, that's how do you convert centimeters. So you have to now find for the distance. The distance should always be meters. How do you convert from centimeters? To convert from centimeters to meters, you also divide by 100. The moment you divide by 100, you convert from centimeters to meters. So how do you do that? We'll get the 400 centimeters. We divide it by what? 100, which gives us what? 4 meters. Now we have searched for the distance, which is 4 meters, and the force is also 4 Newton. So now we can quickly find our work. We can quickly find work now. So work will be equal to what? Force, which is what is the force? 4 Newton. And what's the distance? The distance is also 4. So you are going to get what? 16 joules. 16 joules as the work done. 16 joules as the work done. Remember, we search for the force and the distance. We found the force ourselves to be 4 Newton, and the distance we said should be in meters. So we converted the 400 centimeters given the question to meters. How do you convert the centimeters? We converted the centimeters by dividing by 100. And when you divide by 100, you get meters. So we've gotten 4 meters for the distance and 4 Newton for the force. And now we can now find the work, which is force and distance. So the force, which is 4 Newton times 4, which is going to give us 16 joules. So quickly, let's take another example. A body of mass 25,000 or 25,000, 2,500 grams is raised, okay, 1,000 centimeters above the ground. Calculate the work done. Take G to be equal to 10 meters per second square. Now we have to search for work. So quickly, we have to put the formula down. You have to calculate for the work done. And work now, we know work is equal to force times distance. And I've given you a mnemonic to remember that. Remember work for food, which means force times distance. Good. So here we have tackled a lot of things. Now we know the mass given to us. We have to find the force first. They've not given us the force, so we need to find force and then the distance. When you get these two things, we can calculate for the work. So I'm going to search for the force, or I'm going to calculate for the force. Now, the force we also know is force mass, so which is mass times what? Acceleration. Acceleration. It can be acceleration due to gravity. Now, the mass here, we don't know the mass. We know the mass is given in grams. So we have to calculate the mass, convert the mass from grams to kilogram. And this is going to give us 2,500 grams. We divide by 1,000, which is going to give you 2.5 kilogram. So we've converted the mass to kilogram. So you can now find for the force. The force. So force now is mass times acceleration. The mass is what? 2.5 kilogram. And what's the acceleration? Kilogram. What's the acceleration? The acceleration is given to you here to be what? 10 meter per second squared. So you can now see the force is what? 25 Newton. Or somebody can write 25 kilogram meter per second squared. So it's still the same thing. Now I found my force. The next thing is the distance. The distance. Now the distance here, it is in centimeters. So they've given us 1,000 centimeters. 1,000 centimeters. And 1,000 centimeters here, you have to convert it to meters. And how do you convert the centimeters to meters? I told you centimeters means you divide by 100. So if I divide this by 100, I'm going to get that in what? Meters. So if I divide this one by 100, I'm going to get the units in meters now. So this is going to give you what? This is going to give you 10 meters. So now we found the distance, force and the distance. So now we can now quickly go and find work. And remember, we work for food, which is FD, force times distance. We have, what do we have for our force? Our force, as we've calculated for, was 25 Newton. And then what was the distance? The distance is 10 meters. So we are going to get 250 joules, because the unit for work is joules. Okay, and or somebody can write, if you see in section A, they can write 250 Newton meters, because we multiply force and this distance, so it's going to be Newton meters. So basically this is all about work. Now quickly, because we know work and energy has something in common, we said energy is the ability to do work. And so it means since we are able to find work, in place of work you can find energy. So if you are to solve for work, that of energy, they are still the same thing. So we know energy here, energy should have the same unit as that of work as well. So as I was saying, I said energy. We want to look at energy. Energy and work, and they are twins. I will say they are identical twins. Just to give a little break. Now, energy and work. We said energy is the ability to do work, and so the two of them have something in common. Their unit is going to be joules. We'll have instances where instead of finding for work, you would have to use energy. So we said energy is the ability to what? To do work, and both of them have the unit joules. Now, under energy, so energy here, energy is the ability. That's the definition for energy: is the ability to do work. To do work. Now, under this particular discussion, we are going to consider two types of energy where we can be asked to calculate for. So we are going to look out for the PE here, and we are going to look at KA. Somebody asked, is it physical education? No. This is potential energy and this is kinetic energy. So this we want to stand for potential energy, and then the KE also stand for kinetic energy. Now we'll take them one by one. When we talk of potential energy, remember po here should help you remember position. I will define them one by one. And the kinetic here, we'll talk about motion. You see, it's rhyming. This is talking about position, and the friend, which is kinetic energy, is talking about motion, movement. This is talking about position. So if they ask to define potential energy is the energy a body have at rest or at a position. The kinetic energy is the energy a body have when it is moving. So let's start with PE and look at the formula for PE, and when we are done, we'll look at for kinetic energy. So we'll look at potential energy, and then we'll look at that for the kinetic energy. So potential energy, as I said earlier on, if potential energy, I told you to remember po here means position. So is the energy a body possesses by virtue of its position. All right, so as I was saying, the potential energy is the energy a body possesses by virtue of its what position. So by virtue of what its position, by virtue of its position. Now position, or somebody can say the energy a body possesses at rest. It's still the same thing. The energy a body possesses at rest. They'll still give the mark for potential energy. Is that okay? Now the formula for potential energy is mgh. When you talk of mgh here, I say man go high. If you remember potential position, somebody is the man go high. Just in the morning for you to remember potential energy. That PE, when we are going for PE, all of us, we are very high. We are very hyperactive. We are very happy. So man go high. It means the mass, then the G stands for gravity, acceleration due to gravity, and then the A stands for height. So if you are to find for potential energy, you multiply the mass times acceleration due to gravity and then the height. That is the mgh. So P equals what? Mgh, which is the mass times the gravity times the height. And the what to be the unit for potential energy is also, because it's energy, the unit to be joules. For example, a body of mass 2 kilogram is raised above a height of 3 meters. Take G to be equal to 10 meters per second squared. They say calculate the potential energy. Calculate the potential energy. Now we are talking for the potential energy for this particular question. So our solution. Now we know very well PE here is equal to mgh. Now what's our m? The mass is already in kilogram. Assuming it's in gram, convert to grams to kilogram, but it's already in kilogram. So the mass is 2 kilogram. What's the g? It is 10. And what's the height? Assuming the height is also in centimeters, convert to meters, but the height is already in meters, so times 3. And this is going to give you 6 times 10, which is going to give you 60 joules. So that's how we calculate for the potential energy. Potential energy, you just multiply the mass times the acceleration due to gravity times the height. And make sure the mass should be in kilogram, and then the height should always be in what? Meters. And then you can now calculate for the potential energy. Alright, so quickly, kinetic energy, we said the energy a body possesses by virtue of its position, its motion. The potential energy is the position. So you see the energy a body possessed by virtue of its motion. So we have kinetic energy to be equal to that of half mv square, and the v there stands for, this m stands for mass, this is velocity. So we said half, okay, times the mass times that of what? The velocity square, and that's going to give you the kinetic energy. Now please, sometimes they will not give the velocity and they would like you to find the kinetic energy. What's the formula for velocity? Let's take note of this. Remember, velocity and speed, they are having the same relation. So velocity is distance, or we can say displacement. Distance, the technical term you have to use what is displacement. So velocity is distance over time. So anytime they don't give the velocity, this is how you calculate for the velocity. Distance over time. Remember, speed, the thing is moving. So the thing, because the thing is moving, it should have what? A distance and the time. The time should be in seconds. It should be in seconds, and the distance should be in meters. Then you can calculate for the velocity. Now, our main point of discussion is kinetic energy, which must have times the mass times the velocity squared. Good. So for example, a body of mass 2 kilogram moves with a velocity of what? 4 meters. We'll stop. Calculate. Let's calculate the kinetic energy. Now this particular one, we have to calculate for the kinetic energy. So the kinetic energy, we know kinetic energy is equal to half mv squared. Half, what's the mass? Mass is giving us 2, and what's the velocity? It's giving us 4 squared. Now you are going to get half times 2 is going to give you 1, and the 4 squared is going to give you that of 16. So you are going to have 16 joules as the kinetic energy. So let's take an example. An athlete, this past question, okay, it's a past question of the 2004, question 3. Look at how they frame the question. An athlete whose mass is 75 kilogram runs a 400-meter race in 52 seconds. Calculate the kinetic energy of the athlete. Now here we have to calculate for kinetic energy. You know that kinetic energy is what? Half mv squared. Now half mv squared, we have to find the mass given to us. Now what it didn't give to us is the velocity. Is that okay? We know the mass mv is what? 75 kilogram. Because it's in kilogram, we will not convert. Now the velocity here, they didn't give us velocity, so we have to find the velocity ourselves. And I say velocity is distance over time. Now what's the distance in the question? The distance is 400 meters. And what's the time? The time is what? 52 seconds. So what will we have for our velocity? Our velocity now give us what? 7.6923 meter per second. Now we found the velocity, we found the mass is given, found the velocity, so we can now find kinetic energy. So therefore our kinetic energy is what? Half. What's the mass? The mass is what? 75 kilogram. What's the velocity? 7.6923. And so what will you get here? When you put everything up later, you're going to get 2218.9 joules. 2218.9 joules. This question is so peculiar peculiar or special in the sense that here they've not given you the velocity, so you have to find the velocity yourself. Don't forget, velocity is like distance, speed. Anytime you're checking somebody's speed, you look at what the distance the person has occupied and then the particular time. So distance over time. So we find the velocity ourselves. Then we can now come back to this equation where we say half mass times what? The velocity, and that will be it. So thank you for following up to this session. We'll take a short quiz for you to try on your own, and then we'll come back next time and look at another aspect of this working machine. So the next time we'll look at power and that subsection and this one, and then we'll continue. So let's take this exercise and we run up. So the first question is: a man lifts a stone of mass 150 grams above the ground. If the height of the stone above the ground is 300 centimeters, calculate the work done. Given G to be equal to 10 meters per second square. So this is the answer. So we have to work towards this answer. Work and see if we can get this answer. The answer here we have gotten is what? 4.5 joules. Now the second question is: a book is placed 10 meters above the ground. If the mass of the book is 2,500 grams, calculate the potential energy. Take G to be equal to 10 meters per second square. And so the answer we've gotten is 50 joules. Work towards this. Then what is the kinetic energy of a 2 kilogram mass moving through a distance of what? 400 meters within 30 seconds. And then the answer for this one is also 177.7 joules. So if you go through all this one, you solve it and then you work towards this answer. And so thank you so much for following up to this particular time, and don't forget to subscribe, and don't forget to solve these examples. Don't forget to solve all these examples. And I know with God on your side, you are going to get an A in this particular subject. All right, thank you so much. We'll meet another time.